How have you been?
Fine. I'm currently working on some more Perfetto features, which we can talk about at the end of this time.
So yeah, it'd be wonderful if we could get at that code that you get to see all the time.
I'm afraid that decision is above my pay grade, but I can ask.
Yeah, it'd just be nice. I mean, because of the fact, you get like Microsoft, millions of users, so they have a massive documentation between Microsoft's documentation department, which is probably bigger than Roku,
Yeah.
and then millions of users putting their stuff is over documented. With Roku, we're limited. And, the source would just be a wealth of information. But yeah, I can see how it'd be so just drastically abused. I had never thought of that.
So what information are you looking for that isn't available already?
A lot of times it's just the hows and whys. When you get in, like we're doing a bunch of us do performance testing because we really don't know what's going on a lot behind the scenes.
And you think we do?
Yeah, I would hope you do. But like on the AAs, how are you hashing them? How are you searching them? When does it go from a brute force into what type of tree mechanism? At what point does it become hyper efficient, or does it at some point become hyper inefficient? All kinds of stuff like that.
I mean, a lot of those things are, so giving you the source, yes, there's a specific sort of boundary which NAS calls that the bright, what is it he calls it? The bright script world and the scene graph world. And he's got these, is it scene graphistan and bright scripts, something or other? He calls them. Anyway, that boundary is the place where a lot of the inefficiencies happen.
Yeah.
And everywhere else, for the most part, unless you're doing something with a lot of data, it probably doesn't really matter what you do. I would say, by and large.
And I'm actually much more versed in bright script than scene graph, just because of what I happen to do.
Sure.
I just write a library. I really don't deal with scene graph other than testing.
Yeah.
I'll deal with the bright script objects. But there's times it just, like when we were playing the conversation we had earlier on the rendezvous, is this dangerous to do or is it okay? Why the file system can't be called from render, but the old style direct file access objects can. To me, how we can say things like read ASCII file, write ASCII file, match file, all that from render.
Yeah.
Now, you guys later created a bunch of RO objects to do what a lot of that stuff already did. So you have an RO file system object, you have an RO string ops object. It gave us a lot of what was already there in the general functions, general utility functions. But we can't create an RO file system in render. But we can use the general utility file system commands. The other half of the same puzzle in render. And you get it's curiosity, things like that.
Yeah, some of that stuff is not very well thought through, I would think it's fair to say.
I'm always trying to come up with ways to make Roku a typed system because I hate untyped systems. So like I have that chaining link system I have. But to know how things work internally would help me make that more efficient. Where am I doing something that's just not ideal in the bright script engine? When I have 1,000 functions, or more realistically, 50 functions in an AA, is there a better way to do that? Or am I okay with that? A million questions. So.
Yeah, I mean, maybe we should just have a Q&A but you might find that we quite quickly get to the limits of my knowledge.
And a lot of on something like that, we might not even know what to ask. And just stuff in our timing I find interesting. We were talking earlier on the registry. Writing to the file system, temp file, is slower, is faster than writing to the registry. Reading from the registry is dramatically faster than reading from a temp file. Why?
Yeah, the registry has a little magical object. So when you write into it, it writes to the file and it keeps that thing in memory. And so when you're reading from it, you're no longer reading from the file, you're just reading directly from memory.
So basically cache.
Yeah,
word.
kind of cache.
So, yeah, because it's like if I write to temp and I read from temp, it takes a certain amount of time.
Yeah.
Write to registry takes a little longer. If I read it, it's dozens of times faster. I mean, dramatical difference.
Yeah, I mean, we were just doing some research earlier this year into how much time channels are spending in the registry, and it is quite slow, but I think actually that may be the time spent flushing it out rather than just reading and writing individual attributes. But as soon as you get into more complex structured data, presumably you're then parse JSONing all over the place, I guess.
Yeah. One of the things I do on registry is I do kind of a, for lack of a better word, a setter. So when I start writing things to the registry, it starts a timer in a task. And after that timer counts down a second or two, then it does the flush. That way, if I'm going to stream a couple of quick writes, they don't. I'm not doing a write flush, write flush, write flush. It just starts and it's a resetting timer. So if I write, it starts a 1 second timer. Say, if I write again, it pushes that timer back to a second. Write again, pushes that timer back. So if I do a dozen writes, I get an automatic flush, but it's one flush because flushes are slow. And I believe flushes used to be task only, and they changed it to where you can do it in the render thread now, if I'm not mistaken. But years ago, flush was a task only operation.
That makes sense because yeah, like I remember like being surprised when I was able to do it in the render thread.
That sounds like a bug. Should I go and fix it now?
No.
That'd be a breaking change.
Indeed, I think it's
faster.
90%.
And 10 years ago, or when it first came out, 7, 8 years ago, we had to be careful because the EEPROM could only do so many writes. And I assume that those chips are a whole lot better today and better at blocking and distributing the blocks, all that, to where it's not.
So I think that might be cargo cult.
You think that?
Yeah, I think that might be cargo cult. Because I think so. We still support those old devices. So there are people out there who've got Austins and Liberties. If you've got an Austin, it is now 11, 12 years old, maybe more. Yeah, and that would have had those original NAND parts. As far as I know, they're still going strong. I don't think that there are ever any problems with hitting the NAND erase cycle limits on those parts.
See,
maybe Scott, maybe some of that thinking might go back to some of the stuff that NASA said about some of the old devices getting stuck, not being able to update because of issues with the memory or the storage.
And I'm talking like the old Roku 2XS and Roku 2XD. I mean, this stuff is so.
So those use the same NAND. So Sugarland, for instance, which is a Roku stick, the original purple stick, uses the same NAND parts as Briscoes. There's still lots of Briscoes out in the world, and the Briscoes are all 10 years old now. Morning, Ben.
And these are still that old Toshiba NAND chip from way back when,
or whatever it was. I couldn't tell you what part it was, although I used to know.
Yeah, that's when I took a Roku 2 apart a long time ago. I was throwing it in the garbage anyway. It couldn't up. I think it was a 2 because it couldn't go past version like 3 point something or whatever. No. Oh, wow. Yeah, there were some version caps. It was like 3 point something and then version 9, if I remember. I could be way wrong on that. Hey, Ben.
Hey, hello. Yeah, we abandoned all that first generation chipset. Yeah, before I think we even got to the Shoji UI, the when we upgraded the whole home screen to something with tiles. Yeah.
See, I remember this old when we used to have like the RO springboard screen and the RO. You didn't have any customization. You had a dozen preset screens and you made those work, but it worked.
That's gonna be really crazy.
I mean, that's 2012, 2013.
Yeah.
When I first asked for my switch statement. I actually have a little one I do now that I can, of course, preset an array of functions and then have a little switch routine like everyone has.
Ben, do we need to have a switch statement after this call just to keep Scott happy?
So, but yeah, I can show you posts from like 2012. It's like, when did I have this? So anyway, we are past one. George, this should be being recorded. Hold on, I think he asked.
Yeah, it shows it's recording.
He's asking in one of the channels, and I don't see where. Anyway, Luke, if you want to take it from here, today's kind of your show.
Okay, right. Well, thank you very much, Scott. My name's Luke Diamond. I work at Roku. I'm going to try and talk a little bit about Perfetto. I don't have any slides, so we're just going to be doing like a walk through some stuff. So shout out if you've got any questions. I fully expect things to go wrong, as is the way of live demos. But we'll see how it goes. Right. So I'm going to start by sharing my screen. Well, in fact, no, I'm going to start by talking a little bit about what Perfetto is. So for people who don't know, it's a tool built by Google for Android and Chrome, but it's Chromium, but it's an open source tool. It's actually used in a few other projects that are non-Googlish projects. And it's a tracing tool, so you can put sort of events into your, you can put trace events into your code, and then they come out in the trace stream, and then there's a really nice UI that lets you visualize that. And we'll see that in a moment. We've added support for emitting these events in 15.1, and so if you've got 15.1, then do I mean 15.1? I think I mean 15. I can't actually remember now which release it's in. Maybe it's 15.0. I think it's 15.1. I apologize because these numbers sort of blur into one after a while. Yeah, so the way it works is that you launch your channel, but before you do that, you connect up a client to a WebSocket, and that gets the Perfetto trace data, which is actually encoded as protobus. And if you're interested, there is a protobus schema in the external Perfetto code base, and so you can actually decode those events if that's what you want to do. So I think that's enough talking. I'm going to try and make this actually do a thing. So I'm going to try and share my screen if I can. And this might be quite brave, but that looks hopefully not what we want. So if I come over, so this is actually the Perfetto. This is a Perfetto screen, and we'll come on to how to capture it in a moment. But you get all the events, and then once you open it, you can kind of zoom in. It's slightly weird, but anyone who's familiar with like really old school games will be familiar, because I think it's, what is it, NetHack? So WASD. So W zooms in, and S zooms out, and A moves left, and D moves right. And if you know that, then you're pretty much golden. And then you've got all these events that happen. So and then we can see, so for example, we can see here that what's going on is that the render thread is in this function called consume all tasks, and it's hit this, in this particular case, this channel here, which is just a test channel, it's hit an observer, and it's calling observer callback. This is slightly badly named here in my in the test code that I've got. The function I've actually called is observer, and the field name is value, which is, with hindsight, is pretty stupid, but that would normally be the name of the function, which would be, your function name, and the field name would be, whatever the field name is called. And then here we're executing some bright script, and then we go and call, this thing goes and calls get field, and this is, so it's giving you again here the the thing that you're calling the field on, which is in this case it's a content node, but that in my test code, they are just content nodes. But if this was, you know, your special content node, this would say your special content node. And then the field, again, the field name I've got here is AA, and then it gives you a call stack. The call stack is truncated, but it's enough to get, you know, some information about what's going on. So we're going to come back to that, but that was just to kind of give a sort of overview so that when I'm talking about it, you're not complete, you've got an idea of what I'm on about. And now I'm going to try and see if I can actually go through the process of capturing a thing. So this is what is this? This is I've got a Brian, and I'm going to first of all press the home key, and hopefully that will. There we go. So we stopped. So this is port 8085 on my channel. So I am going to. So there's just a WebSocket. The protocol is the way you connect to the WebSocket is actually documented in the developer documentation, and you can use any WebSocket client you like. So, for instance, there's a WebSocket is one. I've just written a tiny, and I really do mean tiny, Python script here, which just, and all it does is just makes it slightly easier to use. So it's like, that's my code, and the code for this, if anyone's particularly interested, hopefully I've got this here, is Roku Dev. There's a new repo called RokuOS Perfetto Utils. So if anyone's interested, but it is, you know, there's nothing magic. This is just a Python script because I got bored of using WebSo client and having to tell it the file name. So that just this creates files that are named after the ESN, and that's really all it's doing, and prints out some stuff that's going. So this will connect to. So the first thing you need to do is, which I haven't done here, is you need to enable Perfetto on the channel you want. So that's something like, hopefully this is just an ECP command, and then you give the name of the channel. So here I want dev, and it tells you what channels you connect it to. Once you've enabled Perfetto for the channel that you want to do, and it can either be this dev channel or any channel that your device is signed for. Once you've done that, you can then connect your WebSocket up. And it'll sit there, and it's making up a name. So that's the main reason. The main reason I wrote this Python thing is just I got bored of having to put the ESN in the dating. So that's connected, and you can see there's nothing really much going on at the moment because of course our channel is turned off, not running. But hopefully if I can launch, I remember how to do that. There we go. So I can go and launch my channel now. And I can't actually remember which channel this is. This channel here goes, and it just does loads of rendezvous. That's all it does. So I'm going to launch it, and we'll see some stuff. And straight away we start seeing some stuff coming out. And so this is just capturing a load of data. Can I have larger fonts? Let's see if I can make the fonts larger. Terminal. Edit. I'll probably just do that, can't I? Is that going to work? No, apparently that doesn't work. Edit. Preferences. Let's go for a bigger one than that. Hopefully that. Now, is that better?
Yes.
Cool. Okay.
Thank you.
But so yeah, so this is just the output. It's not very interesting. And yeah, I've stopped the thing, and I've now got a capture file. It's you can see it's 9 megabytes. This file here. So now the next step is to go and open that thing. So if I come back over to the other window, and so that web application is a web application. It's hosted very kindly by Google at this Perfetto thing, this perfetto.dev. It doesn't send any data back to Google other than I think it may be sending some usage information, but that's it. But it doesn't send all of your data back to Google. And I think you could just host this locally if you were concerned about that. So here's my trace file, and you can see I've got a load of others. I can open that trace file, and then we've got some events going on here. So now we can see some stuff going on in my channel. So this is the render thread. So this particular channel, as I say, all it does is there's a task thread which sits there doing a rendezvous over to the render thread just as fast as it possibly can. So that's why there's loads and loads of events going here. This is the render thread, which is actually doing some stuff as well. And then this is my task. And this is, I think that's the this UI dev, that's the main, the SDK1 context, you know, where the main sub is. And then down the bottom, we've also got some CPU numbers. So this is showing the CPU is about, what is that? 8%, I think, something like that, not very much. That's a system CPU, and then the user usage CPU, and there's also got some memory stats here as well. Oh, and there's also somewhere, I think right at the top, over here, the use, oh, there is, yeah, it won't be in, there is also a count somewhere of the, I can't actually see it here, not quite sure why. There should be a count, oh, hang on, that's why I can't see it's in there. This is a count of the scene graph nodes in the system. So you can see this is not a very realistic channel. It's got 22 nodes, and they just can't sit there doing whatever it is they're doing. So if if we zoom in, we're going to see what we saw before, because this is the same channel. So we can zoom in here, and then we can start seeing a few other things that are going on as we zoom in. So here, this is our task thread over here, and so it's running some Bright script. It's calling set field, and I've actually got a task called test task, and it's setting a field called value, and this is where it's setting it. And then that actually results in a rendezvous, and you can see over here this rendezvous. This rendezvous sort of came up over to here, and over here is where it got picked up. So in this particular instance, we can see that the rendezvous took 95 microseconds from the point where we said set field to the point where the render thread actually got on and did anything. There's just because, and then there's a few things you can see going on in here. So one thing that you might see quite a bit of is these BSC functions. So there's a few different BSC functions. This one is BSC delete standalone domain. What that is doing is this particular rendezvous is updating an AA field on a content node. And so when you do that update, the very first thing that happens is that the old gate data gets deleted, and that's what we're seeing here. And in this example, it's taking 43 microseconds, so not very long. And then, so it deletes that old data, and then our observer runs, and then we do some other stuff. And then over here, you can see the get field is being called, because we've got I've written some Bright script and does get field. There's get field, and then there's another one of these BSC things, and this one is BSC copy to domain, and that's where that data gets copied from that field into the Bright script world. So this is NAS's Bright script stan, and the other one. So is it NAS? Can you remind me? NAS has gone very quiet.
Sorry, what?
The Bright script stan and scene graph, whatever the other one is called. There's the two worlds between Bright
BRS land.
Yes.
BRS land.
Yeah, so here this BSC copy to domain is copying data from scene graph stan into Bright script land. And yeah, that's taking 54 microseconds. So so that's and then there's various other events that are sort of flying around, but that's the main ones that are going on. In this particular example, that's the main one that's going on. And so the sort of interesting thing is, these rendezvous here, you can see how long they're taking. And in this example, it doesn't take very long, but it is interesting. It actually takes longer than you might maybe expect. You know, that's almost 100 microseconds. But if the render thread is busy doing something, then that can be quite a bit longer. So there's a few other things actually. I mean, so this is not a very interesting channel. There's not a lot going on. There's a parse JSON here, so you can see that's taking 200 microseconds. I think this is where create objects is where creating a content node, and that you can see it's taking whatever that is, 68 microseconds, and so on and so forth. So one thing that you might want to do, well, one of the things that is really powerful about Perfetto, that's what I'm going to say, is you can zoom around and you can see these things like this, but there is also, behind all of this, there's a SQLite database running in your browser, which you can query. So to query it, you sort of jump into this special SQL mode by pressing colon. So if I do press colon, and now we're here. So we can do select star from, and then the interesting one is slice, where name, well, I can do, so it's SQL, so you know, whatever you can think of. So this will pick up all of those BSC copy domains and such like. So then you can then see, you know, we've got all these copy domains going on. These durations are in nanoseconds. So one thing that's quite nice you can do is, because it makes my head hurt to try and divide these. So you can do select dur divided by 1e6 as, oh, can't type. So then that gives you the, because they're nanoseconds, you divide by 1,000,000, gives you in milliseconds. Yeah, so now you get this dual MS. So most of these are actually pretty quick in this example. But yeah, often you'll find that it's quite a bit longer than that. And you can also do things like select sum divided by 1e6 as total. So you can do that. So you can do an aggregation, and it'll give you. So we spent in this particular channel, we spent, you know, just under a second in one kind of BSC copy domain or the other one, all that kind of stuff. So that's, you know, that can be pretty useful to work out what's going on. So if you've got a channel and you're wondering how much time are you spending just copying data around, then you can sort of dig into it with this sort of query to find out what's going on. And then start either reducing the amount of data that's around, or you can use the move into field, move from field, and the render thread queue to try and reduce that copying. And then I think we can just do, you know, then yeah, the last thing you can do is from slice, where we get all those things again, and then you can you just click on these things if you want to find them, and hopefully that's zoomed in on this guy over here. Yeah, and we could click on another one. It's different. There we go. So that's the sort of basics of what you can do. The other sort of thing that's worth, I haven't got an example here, but is also worth knowing is that the just in the same these events here where you've got a sort of an arrow going from over here to over here, this is called a Perfetto flow event. There are also flow events set up for all the RO URL transfers, so you can see where you're sort of starting off the query, what your RO URL transfer, and where the response comes back, which may be useful.
One question, Luke. Yeah, I saw that you enabled for dev, but you can enable this for any app, right? Running on Roku.
Any app where you've got the signing key.
Okay, so if I'm running on a device that I used to sign my app, that will be possible to enable for it. So I can. Yeah. So good. So and then so if I want to like check, detect what's going on in a timeout, this will be useful, right? Because I could potentially identify where the timeout happened. It's
Yeah.
one of the tricky things we have to debug, is because most time the timeouts are happening on packaged apps like live apps, not on dev, and it's hard to reproduce. But if you can trace using something like this, would be easy.
Yeah, I think the problem you're probably going to hit with timeouts is that timeouts are likely to be caused by a few different things. One is going to be running low on memory. So in theory, your channel will get closed before that happens. But in extremis, I think you may start hitting timeouts. But that's only going to. But
but that's not the most common scenario. I think, at least for my use
okay.
case, is mostly like something is wrongly taking too much time to process data of the render thread and everything. So, but when you get the stack traces for the crash, you see some random place because it was not the root cause. But if you can have a trace, it will be easier.
Yeah, so then I think in that case, yeah, you could certainly do it, and you could be interesting to see whether you're able to capture the information you need. I think if you don't, it might be quite interesting for you to you get back to us and let us know what's missing.
Yeah, I would try to force a scenario.
Yeah. One other thing that's just interesting, just worth commenting on, is that print is surprisingly slow. If you remember that my channel on port 8085 was spewing out some stats on each line, it's taking sort of almost 100 microseconds to do that print. So that's worth bearing in mind. So that is sort of basics. Are there any more questions before I just move on?
One question. So obviously it seems like this is designed to be able to be used, besides side load. Like, what is the cost of creating the RO Perfetto object or like that? I assume obviously most of it is not turned on if you're not in developer mode, but just curious of the overhead.
So I don't actually know how long creating the RO Perfetto object is. So that's actually coming on the next part I was going to talk about, which is adding the branch script tracing. So you're sort of getting slightly ahead of me, but that's fine. But it should be pretty small. I mean, it's really not. I mean, all it's doing is creating a component. So it'll be similar to the cost of creating an AA, for instance.
Okay.
So yeah. So okay, let's talk about adding your own trace points. So now where did I? So I put some. Hopefully, I've put some code in the right place. Where am I then? Here we go. So this is a sample channel created by Chris Hagedorn, doing some slightly different stuff. But what I've just slightly modified it here. So I think hopefully I can do this pretty easy. So I've got a few things going on here. Which, and hopefully we can just see where I've made these changes. Oh, I've got Control M's there. I have to fix that. What I've done is I've created an RO Perfetto object, and that lets me add my events. And then I've created an instant. An instant event is just a single thing in time, so like a key press. And I've created one called Luke-program start. And then I've created another one called Luke-show screen there. And then I've got another event over here. So I'm doing a begin event, and this is I've called it Luke append children because of that course function called append children. And then there's an end event, and these things are scoped. So you need to if you do a begin, you need to have a corresponding end that lines up. And if the end event gets truncated or lost in some way, then Perfetto does get quite confused about what's going on. And then I've added this function called do test, and I don't know if we can't make that go back. Let me try again. I'm on a slightly weird setup here. Let's do that again. Do test. So yeah, that creates a scoped event. So the scoped event is one where you create this object, and when the object goes out of scope, then the event gets stopped. So it's like doing begin event and end event, but you don't have to output the end event yourself. So this one will do a scoped event and then sleep for 100 milliseconds, and then we're leaving the function so that scoped event gets destroyed. You can also create a flow event, just like the ROU transfers and the rendezvous. So you can have a flow event if you want. That's identified by a number. I haven't got an example here, but it should be very straightforward to do. So I captured that. This is actually a different channel, but I'll go through the capturing process again. Actually, it's worth going through the capturing process because there's a few very small gotchas that are just worth mentioning when you're trying to get going with this. So one is your channel has to run as you need to run as a process. Yeah, you can't run in application. So you need that run as, the run as process equals one thing in your manifest. You'll want to have that set. Then the other thing to watch out for is, and just in preparing, as I tripped over this a dozen times, is that it only enables Perfetto at the point where you launch the channel. Yeah, so if you launch your channel and then enable Perfetto, it won't do anything and you'll get an empty trace. So you need to kill off the channel, turn on Perfetto, then launch the channel. So anyway, if I go and rerun my magic script here, and yeah, just to reiterate, I've got this Python. You do not need to use that Python script. There are, other WebSocket clients out there you can use instead, as long as they don't. It uses the binary protocol of WebSocket, so just as long as it doesn't corrupt that. I think there are plans to integrate this into the Brighter script debugger, but I don't think that's been done quite yet. But anyway, so we fire that thing up. And then I think I've got this thing over here, and then so now my channel is running, and I'm going to press, and I think press S goes and does something. So now it starts doing some stuff, and yeah, again we've got a 8.6 megabyte capture file there, and then a bit of luck I can come over here and I can go open address file. So it's this one here that's just been done, and so a load of events. This is doing a lot more than the previous one was doing. Another thing to maybe worth looking at is swap buffers. So that's so swap buffers is quite an interesting one to see. Because you can get an idea if you're dropping frames because there'll be big gaps going on. Anyway, so we can do select staff. This is someone slice where name like. Obviously, I haven't tested this, so there's every chance it won't work, but we'll see what we get. There we go. We get our events that I put in. We were talking about earlier. So we've got this guy over here. So this is one I put right at the start. So you can actually see there's a little bit of stuff going on between where the channel actually starts and where main happens. And then the next one is this guy over here, which is so I think we can zoom in like this. Okay, we can't. You can zoom in and you can see that those two events were basically really close to each other. Yeah, so that's my start, and that's the I think that's a rendezvous. Where is it? Can't find it. Okay, I'm lying. But anyway, so those are those two events that we had earlier. And then this is the other events we're talking about. So this is that append children thing that I created, and then you can see over here the next one down is this other thing called Luke scoped. And you can see, yeah, so it's just about 100 milliseconds. If you remember, those of you who you might remember from I didn't point it out, but the code in that append children event, I actually passed in some parameters, and so you get these arguments over here. Let's just go back to the code there. So if I come back over to here, yeah, so you've got this food column 42. So you can pass in parameters, and it'll show up in the trace, which might be useful. Okay, and I think with that, I think that's most of what I wanted to cover, really. Have I missed anything from my list? Yeah, I think that's pretty much all there is to it. So, yeah, I do encourage people to give it a go. I think it's a pretty useful tool. It's amazing the things you'll find if you start looking through. I've found looking at quite a few channels, I've found a lot of things that are really quite surprising, and I wouldn't ever have expected. Lots of things that take much longer than you might imagine. So, yeah, like find node, for instance, can take a longer you might think. Lots of rendezvous where you might not expect them. So yeah, definitely, if you care about how long your channel is taking to start up or to do things, it's definitely worth taking a look. Anyway, that's all I've got. Questions?
I had two.
Go on.
Last week, if I remember, or last month, if I remember, you said this is not a replacement for the profiler, but it actually seems like an awesome replacement for the profiler.
Oh, right. So that's a really good question, actually. So, because I mean, first, so it's not, the reason it's not a replacement for the profiler is because the profiler gives you line by line execution times, whereas this currently does not. So, so if we look at this Luke append children event that we've got over here, that doesn't tell you anything. If you remember, we were calling that function, I can't remember what it's called now, do thing, I think it's called. There's no information here that we're inside do thing. And it would be kind of useful to have that information. You can imagine it'd be very useful to have that information. So I think that's not in 15 point whatever this current release is, but we certainly do plan to get that in. That is on the roadmap. So for later in 2026. So at that point, I think it would be a pretty full replacement for the profiler.
Okay. And
you said you had two questions.
Yeah, the other was, you talked to Brian a minute ago about that as a minor cost, like creating a way of actually kicking this in. When we get these nanosecond level timings, does the fact Perfetto's running have enough of effect, have a substantial effect on the runtime? Or when we see timings on this, is that going to be fairly accurate to what we would expect on a live system?
So it's pretty close to a live system. The caveat is that getting call stacks is quite expensive. So I think anything where there's a call stack, it probably will be somewhat slower. And I think that's one of the reasons why we, so there was, I did put in an initial attempt at trying to do the profiling. And the thing you run into is that if you do that, then it is much, much slower. It's like, well, it's just I mean, it's not unusually slow, but it is really slow. So we need to solve that problem before we can do, before we can go and do that. I think if you, for just an event where, like one of those custom events, it's sort of down at the sort of microsecond level.
Okay, that makes sense. And I've always looked at it. If it's fast enough for me in testing, and it's probably because of the testing mechanism going to run faster in production. So if I'm happy with test speed, I'll probably be very happy with production speed, is usually the way I've looked at things, because testing always slows it down in some way or another at some granularity. Anyway, you've answered my questions. Thank you.
Okay, cool. And actually, your question about the call stacks reminded me that the other feature that I mean, Perfetto has loads of features. It is an amazing tool. The other feature that Perfetto has that we're hoping to take advantage of, and so this is like forward-looking. So I'm not promising anything, and we might just turn around and say, well, we're not doing it. But the hope is that Perfetto has support for showing like a heap graph, where it will show you all the objects in your heap and the relationships between them, and how much size they're all taking. So we're hoping to try and get that into 15.2. And yeah, so hopefully that will then be quite useful for tracking down memory leaks, because you'll get the ability to go and I think you get a kind of a big sort of diamond shape on the graph. You can then click into there and you then see, oh, I've got all these content nodes, and here's all these objects, and this is what here's a load of objects I wasn't expecting to have, and this is the path that's keeping them alive. Yeah, so that hopefully that will be quite useful once it comes out. So that's forward-looking. I mean, it's not a secret, because I mean, it just isn't. Well, it isn't now. But yeah, it's possible that we'll find some insurmountable problem that means we can't do it. But I'm hopeful that that won't happen.
Yeah, I can see where this would be nice. I was used to stuff like this from the old C# days, and I missed it. When you could get down to that kind of granularity on timing, because it tells you where to put your optimization efforts.
Yeah.
Too many times you see a big chunk of code, think it's the problem, and it turns out it's these 3 little lines you didn't think, but they execute 17 million times.
Yeah, I've seen a lot of things where where, as you say, there's some quite surprising places where huge amounts of time just disappear.
So been there, done that way too many times.
Did you keep notes of your observations, Luke? Like you said, you looked at a bunch of channels, and even if it's not a formal or prescriptive, like if you have a list of curious discoveries. Over.
Okay, so the big one for every channel is BSC copy to domain, and which is copying into an AA field and copying out of it. And you look at any channel, and that's where the bulk of the time is being spent. And looking just at this test channel I've got here, the other thing that you realize is that the cost is not only copying things in, but also whatever was there before needs to be deleted. Yeah, and that's also really expensive. Parse JSON is also has a similar sort of thing going on. Parse JSON is actually quite fast these days, but when you do m.thing equals parse JSON, or whatever it is you do, but when that variable gets destroyed, that's getting rid of some giant forest of AAs, and that is also really expensive. There isn't any sort of magic thing you can just make that go faster, but you can just having less data around helps. And then for when you're shoveling data into fields, you either move from functions that you can use now to make that go faster. As I said before, the queuing as well, which avoid a lot of that overhead. So that's one thing. Another one actually that's quite interesting is get field. So get field, I think. Sorry, no, what am I talking about? Not get field. Find node. That's what I mean. Find node. I think if you come from a JavaScript background, you probably expect that find node is order 1 and really fast. It is not order 1 in SceneGraph. It is order n probably. And it's more complicated than that, but it can be order n. So I have seen channels where find node is using quite a decent amount of time. What else have I seen? Another thing that I've seen, and I think this is a bug, but it's such a hard bug to fix. If you're in a task thread and you are setting up observers to signal a message port, then each of those observers is a rendezvous. Yeah. And oh yeah. Go and try it out, Nas. Okay, so I've not had time to really dig into this. All I can tell you is what I saw, which is task thread was doing observe field. Each of those observed fields is a rendezvous, and each one was 16 milliseconds apart. So
just the call though. After that, getting messages on the port.
No, just setting up observers. Let's start
I
today.
think you could avoid that by setting them up in the init of the task, correct?
Yeah, if you do in the init, that's running in the render thread, so that will have delays.
Yeah, how do you get to the message port then? Would that still
Well, you create the message port in the.
Oh yeah, no, that's right. Yeah, you are.
Message port gets transferred when the task thread is started. It's one of the actually nothing to do with blessed because M is transferred. Over.
Yeah. So what other things have I seen? I think another one that I do see around is our device info, the get display size operations can be quite slow. So if you call it once or twice, that's fine. But I've seen channels where it's calling it, thousands of times. That can be quite slow. Just lots of rendezvous.
That's slow. I mean, shouldn't it like the first time it gets called, cache it?
I was
I think that's something. Sorry, was that somebody saying something?
I was thinking the same thing Nash just asked. On the first call, couldn't the OS just cache it so it knows from the rest of the application?
Yeah, I think unfortunately we don't, and that's something we're working on to fix in 15.2.
And you said is get the screen size, the device.
Yeah, so that can be quite slow.
And actually that's buggy. I actually put in a
yes,
bug
I saw
report,
your I saw your comment, and it made I wasn't quite sure what to make of that. But I think that's a slightly orthogonal problem. Another thing that you do see is the swap buffers taking a really long time, and that can just be because there's a lot of pixels to wade through. So if you've got a scene and there's just lots and lots and lots of stuff going on, lots of images being composited, then swap buffers takes longer and longer and longer. That's certainly worth looking at. You can't really see that from this view because this doesn't show you what's on your display, but you can see those those swap buffers being extended out way beyond.
Yeah, but you're talking about the scene graph behind the scenes swap buffers, right?
Yes.
Yeah. Okay.
Yeah.
But
Scene graph has some optimizations to try to hide, basically not draw things that it knows are hidden by other things on top. But some of the operations, some of the translation of other things can leave it not being able to determine that. So you get overdraw, and basically the GPU is drawing all the stuff and then drawing right on top of it.
Yeah, I think sometimes it just can't be avoided because you've got situations where you want to draw an image and you want to draw a gradient on top of it, and then you've got to draw it twice. But if you do lots and lots of that, now you've got lots of gradients going on, and it just gets expensive. You run out of CPU time or GPU time, I should say.
But isn't there it's not really an issue, but isn't there with swap buffers that it waits on vsync because you have only 2 buffers on some devices?
I mean, it doesn't matter. So this is not a problem of that. So I think we're I can't actually, maybe Ben, I can't remember if it's double buffered or not, or triple buffered. I think it's double buffered. But this is more that we're just running out of GPU time, so it doesn't really matter how much buffering you've got.
Yeah, I think we actually try to be triple buffered on most platforms for the main screen, but I'm not 100% sure.
Yeah,
right, but even the triple buffer will have a problem if 2 buffers are already full. and waiting.
Well, no, the whole idea with the triple buffer is that if basically if you ever in that situation, it's just going to pick a different buffer to draw into and drop one.
So there are two different implementations on triple buffers, and Roku's, I believe, does not take the free one. It just gets 1, 2, 3, 1, 2, 3, 1, 2, 3.
Yeah, I talked with a graphic architect about that. I think we may fix that.
But yeah, I think the underlying problem is drawing things, and there's just too much going on, and it's running out of GPU time.
Yeah, at this point, this number of buffers was exposed at some point to the row screen, arrow screen. But now I think it was fixed because it's all double buffer. I don't see 3 buffers anymore. But some devices had 3 buffers. The Roku 3 that I had to do two swaps sometimes to clear screen because of that. But now I don't see that anymore.
Yeah, I remember that being fixed a few years ago.
That would be a bug though, because from the point of the API, you only have 2 buffers. Like the third buffer is internal thing.
Yeah, but it was exposed at some point. It was exposed because in my games I had to do two swaps to clear screen because sometimes it would not clear because it was.
I understand. I'm just suggesting that this was a bug and that was fixed.
Yeah.
Can I go back to Find Node for a second? You mentioned the Find Node is rather expensive.
Mhm.
Could we get it? Going on the assumption, if I'm going to, in my XML, put IDs on nodes, I probably want them in the code, and I'm going to find node them. Could we get a find all nodes that just in a single pass gives me an array of everything that had an ID, assuming I'm going to want it anywhere? I wouldn't have bothered putting an ID in to begin with.
So on the find node performance, I think the way it works is that objects that are defined in the XML, there is a dictionary lookup. So then the search time is log n. But it's objects where you just add it sort of programmatically after the event. Those are the ones where the search time those are going to take longer.
Okay.
Yeah, I think that's what causes the problem.
So I was thinking you just meant the XML ones, and like that would have been easily fixed. So
yeah, no, the XML one's log n. But if you then create a load of other things that are named and you pop those into your tree, searching for those is order n.
To be clear, it's not a thing of like after you add those that like basically it's based off the ID of those items. Like if you do a find node before you create some things in the Bright script, and then you do a find node afterwards that is also for something in the XML, those will still be fast. You're just saying if you create something and then try and find it, that's
Yes.
what's slow. Okay, good to know.
Is this fixable?
Potentially, yeah.
I mean, because the caveat is that you will have to remove from the dictionary the remove nodes from the subtree. It just feels unsettling that the XML part would be faster, but the dynamic one won't be, and there is no way to know other than, oh, hey, you wrote this program if you're a single developer, so you should know.
It kind of makes sense though, because like, I mean, the purpose of find node is for you to be able to get a reference to the node. If you made the node yourself, you're able to store a reference to it.
you should already have the reference. Yeah.
Yeah.
No, but there is no API that you can speed it up. You're just left with use XML to do the stuff that you want to be found fast. And that's fairly limited because you cannot have your program statically in XML, right? Over.
Yeah,
So you can do a find node from. I don't want to spend the entire thing talking about find node, but you can. It's the number of objects underneath the point where you start searching for. So you do have a way to.
So first, this is completely new knowledge to me. But so when you do find node, first it will use the dictionary, and then if it cannot find it, it will do a depth first search, right? Root left, right.
Yeah, I can't remember whether it's depth first or breadth first,
But that's incorrectly to call it breadth first.
from the node where you've asked it from the node where you started from.
Yeah, but it's a depth first search. If you go to the whole left tree before going to the right tree.
I don't know if this has changed in the last year or two, but I know at least before, even like let's say that you specify a different node than mtop for the find node, it's still always relative to mtop. Like it's basically it doesn't seem like it seems to care what node you're calling find node on. It's the scope of the node that you're actually in.
Yeah, you might be right about that.
But what I remember about the search here is that it's going to look at all the direct children of the current node it's searching to see if any of those have the ID. If it doesn't, then I'll basically depth first search all those children.
Mhm.
So yeah, that's why it's not just direct depth first search, but it's not really breadth first search either. I guess
Right,
maybe
that's a good clarification.
Yeah.
First its own children, and then recursively calls all the children.
Try it the easy way and then go to the hard way.
So how does it know which is the component when you call it? Or is it based on the context of the code?
I'm not actually sure.
Well, just a point of clarification, because it didn't look like you were sure if it's 15 or 15.1. At least the documentation is saying 15.1. So yeah, definitely looking forward to the betas or whenever this will be coming out. So
Yeah, if we're talking about Perfetto, that should be in 15.1.
Yeah, 15.1 beta is already out. If you are in a beta program, you should have it.
oh, interesting. I haven't seen on any of mine, but I'll check
Yeah.
for updates.
yeah, I know 15.1 is just starting to release to devices. I think even beyond beta. So
Okay.
but it's still very early stages of rollout. I think plans on that to, aiming for January, because we have all these blackout dates right now around Black Friday and Christmas. So
Mm-hmm. Thank you for sharing, Luke.
Yeah, I think we're out of
Thanks.
questions here and pretty good on time too. I think it was last month we kept you here for 2 hours.
Okay, cool. If there are any more questions, if there's anything you want to know, please ask on the Slack. And otherwise, I guess we'll finish that.
I appreciate it.
Thank you,
Thanks
Luke.
very much, everyone.
Thank you, everyone.
Looking forward to using this.
Mhm.
Okay.
Yeah, for sure.
Everyone take care. We'll see you in a month, but it will be back to the normal Thursday schedule probably.
Okay.
All right.
Bye.
See everyone later.